In 2025, China launched more ships than every other country on Earth put together. Not by a small margin, by more than double. Right now, nearly 70% of every new ship being ordered anywhere on the planet is being built in China. That means the majority of ships that will carry the world's oil, gas, and cargo for the next 30 years have already been designed, ordered, and are being assembled right now in Chinese shipyards. These are not small vessels. These are oil tankers so massive that 3 football fields fit inside their length. So tall that their engine alone stands as high as a 4-story building. So powerful that a single voyage carries enough oil to meet 10% of America's entire daily consumption. The United States is watching all of this very carefully. And the more they look, the more uncomfortable the picture becomes. Because this is not just a story about ships. It is a story about who controls the flow of energy on this planet. And that race is already over. How a 3-way competition became a solo sprint. For decades, shipbuilding was a competition between 3 countries: Japan, South Korea, and China. Japan had the experience and precision that came from generations of craftsmanship. South Korea had cutting-edge technology and a reputation for speed. China had the scale, the workforce, and the hunger to grow faster than anyone expected. Western nations watched this dynamic and felt comfortable. As long as those 3 kept competing with each other, no single country could grab too much control. It felt balanced, stable, safe. Then China stopped playing the same game. It did not get better at building ships the traditional way. It went back to the drawing board and rebuilt the entire system around how ships are made, from raw steel to finished vessel, from the ground up. It changed the rules entirely. And once you change the rules, the old scoreboard stops mattering. By 2025, China was producing 69 million deadweight tons of ships in a single year. That represents more than 56% of everything built on the entire planet. South Korea, which was neck and neck with China just a decade earlier, was watching from a significant distance behind. Japan had fallen even further back. The 3-way race had quietly become a solo sprint. But the order books told an even bigger story. Nearly 7 out of every 10 new ships being ordered anywhere in the world were going to Chinese yards. The global fleet of 2040, 2050, the ships that will still be sailing when today's teenagers are middle-aged, is being shaped in China right now. When you control what gets built today, you control how the world moves tomorrow. What these ships actually are: a very large crude carrier, what the industry simply calls a VLCC, is one of the biggest moving objects ever created by human hands. 330 meters long. That is 3 football fields placed end to end. 60 meters wide. It carries around 2 million barrels of crude oil in a single trip. The United States uses approximately 20 million barrels every single day. One of these ships carries roughly 10% of that in one voyage. One ship. One trip. The steel alone that goes into building a single VLCC weighs about 55,000 tons. Roughly the same as 7 Eiffel Towers stacked together. And every plate of that steel, every cut, every weld, every joint across that entire mountain of metal has to be close to perfect. Not good enough. Nearly perfect. Because the ocean does not forgive shortcuts. Waves in the North Atlantic can bend steel beams. Pacific storms have swallowed ships whole. And inside the hull, 2 million barrels of crude oil does not sit still. It sloshes. It surges. It slams against the walls with every wave, creating internal pressure that shifts constantly and beats on the structure from the inside out. For decades. A ship like this has to survive all of that continuously for 25 to 30 years. And China can build one from raw steel plates to a sea-ready vessel in under 2 years. The method that changed everything. Traditional shipbuilding started from the bottom and worked upward, 1 layer at a time. The process used to take 4 to 5 years. Chinese engineers broke the entire concept apart mentally. First, They take the blueprint of the ship and slice it into more than 100 giant sections on paper. Each section weighs between 300 and 600 tons. Then they build each section completely separately on the ground, adding pipes, electrical wiring, and protective coatings before it ever connects to the main structure. Then massive cranes pick these finished sections up and lock them into position like the world's most expensive jigsaw puzzle. This is called modular block construction, the same thinking aerospace engineers use when assembling rockets and satellites. Instead of doing everything sequentially, one step waiting on the last, dozens of things happen simultaneously and come together at the end. A ship that used to require 4 to 5 years of construction is now finished in under 2. And the quality does not drop. In many ways it improves, because each section can be inspected and perfected independently before it ever becomes part of the whole. The technology behind the precision. Taking 100 giant steel blocks, each weighing hundreds of tons, and making them align with each other to within a hair's width. That is the problem that could break the entire system. Across China's biggest shipyards, millions of tiny sensors are embedded throughout the entire construction environment. These sensors feed data continuously through high-speed networks into AI systems that monitor every measurement, every position, every tiny movement in real time. If a section shifts even slightly out of alignment, the system flags it immediately. Not when a worker happens to notice. Immediately. The deviations this system catches are not the size of a finger or a coin. They are the size of a human hair. And in a structure this large, that level of detection is what prevents small errors from stacking into catastrophic ones. An error of a few millimeters on section 5 becomes a few centimeters by section 50, and a serious structural flaw by section 100. By catching and correcting them instantly, this network guarantees that when those blocks come together, they fit like they were always meant to be one piece. Then there is the welding. Every joint on a ship has to hold for 25 to 30 years, in salt water, under constant load, through storms, through thousands of tons of shifting liquid, through temperature extremes from the tropics to the Arctic. A human welder, no matter how talented, gets tired. Speed shifts, pressure changes. Over thousands of continuous hours, even the best human welders produce inconsistencies they cannot fully control. So China handed the most critical welding to robots. Laser welding arms work around the clock on steel plates up to 50 millimeters thick. They maintain the same temperature, the same speed, the same pressure, for hours, for days, without variation. The joints they produce are not just strong, they are consistently strong everywhere, every time. The combination of modular construction, AI-guided precision monitoring, and robotic welding is not simply a faster version of traditional shipbuilding. It is a fundamentally different way of thinking about the problem entirely. The new generation of ships nobody expected. China's newest tankers do not just refine what came before. They represent a complete philosophical shift in what a ship is supposed to be. The Jin Aden is a VLCC, with a dead weight of around 300,000 tons. But what makes it unlike anything before it are the structures standing on its deck. Rigid sails, 40 meters tall, built from ultralight carbon fiber. Standing on the hull of a ship the length of 3 football fields. Designed not for appearance, but to generate real supplementary thrust from wind. These are not decorative callbacks to the age of sailing ships. They are aerodynamically engineered structures that capture wind energy and feed it directly into the ship's propulsion system. Under real-world conditions, they reduce fuel consumption by 9.8%. On a ship that burns vast quantities of fuel every day, across 30 years of operation, that percentage saves millions of dollars per vessel. The Yuan Ruiyang takes a different approach. It runs on a dual fuel system that switches between traditional diesel and liquefied natural gas, depending on fuel costs, port regulations, and environmental standards in whatever region it is traveling through. 333 meters long, 60 meters wide. The dual fuel system cuts carbon dioxide emissions by 20%. and slashes sulfur emissions by up to 85%, meeting international environmental standards that most older ships in the global fleet cannot come close to matching. And the newest generation of Chinese tankers is built to last 30 years instead of 25. 5 extra years sounds modest in isolation. For a ship carrying millions of barrels of oil per voyage, those 5 years represent hundreds of millions of dollars in additional operating value. The power nobody voted for. Here is the part that most coverage of Chinese shipbuilding completely misses. About 60% of all the oil traded anywhere in the world travels by sea. Not by pipeline, not by truck, not by train, by ship. And the vast majority of those ships were built in China. That single fact creates a direct and permanent link between Chinese industrial capacity and the global flow of energy. Every barrel of oil that moves from the Gulf to Europe, from the Middle East to Asia, from West Africa to the United States, overwhelmingly travels on a ship that a Chinese yard built. But it goes further than where the ships were made. When you build the ship, you do not just sell a product and walk away. You create a relationship that lasts for the entire operational life of that vessel. The shipping company needs spare parts designed for that ship's specific systems. It needs technical support from engineers who understand how it was built. It needs maintenance services, software updates, and eventual upgrades. All of that comes back to China, over and over, for 30 years. Chinese state-owned banks made this ecosystem even more powerful by changing the financial model entirely. A VLCC costs hundreds of millions of dollars. Most shipping companies, even large ones, could not just write that check. Chinese banks came in with financing packages that spread the cost over time, with competitive interest rates and flexible terms. Shipping companies from Greece, Norway, the Middle East, and across Asia started placing larger orders more frequently because the financial math suddenly worked in their favor. And every one of those orders deepened the long-term connection between those companies and the Chinese shipbuilding ecosystem. For most of modern history, power in the global energy system sat with the countries that had oil in the ground. Saudi Arabia, Russia, the United States, the nations that could turn a valve and move prices. But oil in the ground does not go anywhere without ships to carry it. And ships do not exist without shipyards to build them. China is not setting OPEC production quotas. It is not drilling in the Gulf, but it is building the vessels that carry 60% of all the oil the world buys and sells. And the ships being ordered and built right now will still be sailing in 2055. That is not a shipbuilding story anymore. That is a story about who holds the quiet levers of the global economy, not through military force or political pressure, through steel, robots, carbon fiber sales, and financing terms that make it easier to say yes than to say no. The ocean is starting to look less like a natural boundary between nations and more like a network that somebody built, somebody maintains, and somebody increasingly controls. When 60% of the world's oil travels on ships built, financed, and maintained by one country, does that country hold a kind of power over global energy that nobody voted for and nobody can easily undo? Drop your answer in the comments. Subscribe and hit the bell. Next one is already coming.